Welcome to our Chapter 9 review for Physics. In preparation for the exam, we're going to review a sled problem. The sled problem is a common problem in physics, which we'll be dealing with in this problem. It says the problem says a child is pulling a 20-kilogram sled. It says packed with supplies to the right with a rope that is 35 degrees up from the horizontal. If the coefficient of static friction is 0.112, what force must the child pull the rope in order to get the sled moving? Okay, so the first thing I want you to do, I want you to draw a free body diagram. The force that the child is going to apply is going to be 35 degrees up from the horizontal. The horizontal will be here. So we're going to draw 35 degrees. And we want to know what this force is going to be, which I called it H, but we'll call it force. Okay, now, what other forces are acting on this point? First of all, since the sled has mass, it's going to have force caused by weight, since there's gravity. So, force caused by weight. When we have force caused by weight, we're going to have a normal force which is going to be perpendicular to the surface that the sled is on. Since the sled is on a flat surface, it's going to be directly up. So it's going to be in the opposite direction of the force caused by weight. So the normal force is acting up. There's one other force acting on this point, or this sled, and it's going to be the frictional force, which is acting in the opposite direction of the force that the child is applying. So the frictional force right here. Now, in order to solve this problem, what we need to do is we need to sum the forces about y and sum the forces about x. Let me tell you, the reason we sum the forces about y, even though the sled is not lifting, is because we have to have the normal force to solve for the force caused by friction. So let's begin by summing the forces about y. To sum the force about y, we have to split this before we sum these forces, we need to split this vector into its components, because we have to sum forces that are on concurrent vectors. In other words, vectors that are acting along the same line. So, to split this vector into its components, we take the hypotenuse, which is F. This is the force about y. We take the hypotenuse times the sine of the angle. Now, that gives us this force right here. We're going to split this vector into its components. So, this gives us the y direction right here, and then the x direction is going to be given by this little vector right here, and it's going to be called f cosine of 35. So we'll write those in. F sine of 35 and f cosine of 35. Okay, so we can get rid of this vector now because it's represented by this vector and this vector. And now that we've split this vector right here into its components, we have all concurrent vectors. All of them are either acting in the horizontal or in the vertical direction. So, first thing we want to do is sum the forces about y. So let's do that. If it's acting up, it's positive. If it's acting down, it's negative. So the normal force is going to be positive. It's acting in the up direction. The force that is applied by the child in the the component of the force that's applied by the child in the up direction is going to also be positive. So it's going to be plus F sine of 35. And the force caused by weight is going to act down. And by the way, the force caused by weight is equal to mass times gravity. So we'll just go ahead and put that in. Mass times gravity. Okay, I'm going to take this right down here so we have a little bit more room to work. Let's begin to put input values into this so that we can solve for the normal force. The sum of the forces about y, first of all, let me state that it is equal to 0. This variable right here, this is one variable, it's going to be equal to 0. The reason being is because this sled is not moving up when it's not moving down. It's staying stationary on this surface. So, if we state that this is 0, and then we solve for the normal force, we can put that into the frictional force to solve we can put that into the frictional force equation to solve for the frictional force. So let's do that. Again, this is equal to 0, so we'll put a 0 is equal to the normal force, which we do not know yet, plus the force times the sine of 35, we do not know the force yet either, minus the mass, which is 20, times gravity, which is 9.8. So, again, we have to solve for the normal force because we're solving forces about y, and that's the goal of this, is to solve for the normal force. So, we're going to do that. Negative f sine of 35, I'm moving everything except for the normal force to this side, plus 20 times 9.8 is equal to the normal force. So let's go ahead and simplify this a little bit farther. I'm just going to go ahead and put these values into here. If we say, we'll go ahead and do the sine of 35. So we have, it gives us a value of negative 0.574 times f. I simply solve for the sine of 35 and multiply it by a negative. Plus 20 times 9.8 is 196. This gives us our normal force. So the next step, once we've solved for this normal force, now what we're going to do is we're going to go back up here and we're going to start solving for the sum of the forces about x. So the sum of the forces about x is equal to, if it's acting to the left, it's negative. If it's acting to the right, it's positive. So the force acting in the right direction is f cosine of 35. The force acting in the left direction is the frictional force. And what we're going to do is we're going to, instead of writing just frictional force, first of all it's negative because it's acting left, instead of just writing frictional force, we're going to write its substitution. In other words, we're going to write the right side of the formula, inputting the values as we go. These values here. So the frictional force is equal to the coefficient of static friction, which is 0.112, times the normal force, which we solve for here. And it's going to be negative 0.574 times our force plus 196. Now, I also want you to note, the question is, what force must the child pull the rope in order to get the sled moving? And it's really the instant before the sled begins to move. In other words, the sum of the forces about x need to be equal to 0. This is essentially going to say that the sled is getting ready to move immediately after the child exceeds this force. So if we sum the forces of x is equal to 0, then we can say f, I'll begin to solve for this, f cosine of 35 minus, and I'm going to start multiplying this through, 0.112 times, it's actually going to be a negative 0.112 times a negative 0.574 and that gives us a value of 0.064 times the force. And then we're going to multiply this through as well. It's going to be negative 0.112 times 196, which comes out to be a minus 21.952. Okay, now we're going to add this together. First of all, let's go ahead and do cosine of 35. So the cosine of 35 is, so rewriting this, the cosine of 35, I'm just going to tack it onto the front. It's just a number. 0.819 times the force minus 0.064 times the force. And let's go ahead and move 21.952 over to the other side. So instead of 0, it's actually going to be 21.952 here. So adding these coefficients together, or actually subtracting them in this case, gives us 0.819 minus 0.064. It'll give us 0.775, or 755, sorry, times the force is equal to 21.952. Now we divide both sides by 0.755. And our force is going to be equal to 29.075 newtons. This is the force that the child must pull on the rope in order to get this sled moving. Okay, as you can see, this is a fairly complex problem, but if you just take it step by step, it's not too bad. Remember to begin with a free body diagram to get a picture, and as you progress throughout the problem, it'll start coming into shape what we're supposed to do. Okay, and so this is the answer to our problem, and that concludes this problem.